How's everyone doing? Everyone studying for finals and, I don't know, finishing projects? Nice. Okay, so, yeah, today's gonna be pretty fast, so, it's good for you, so you can work on projects and your finals, so, yeah. So before we get started on basically just talking about the study guide that I have here, there are a few announcements. So the first thing is that your SOQs for all of your classes, they're due by today. So please fill out the SOQ for this class today. After class, it just takes 2 minutes to fill out. So you can see that on the homepage on fullerton.edu when you sign in, or I'm sure you got like 1,000 emails from the school. Yeah, I'll talk about the final in a sec. So SOQs, again, make sure you fill that out today. And then also there's an indirect assessment survey. And I think you got an email for that as well from Nathan from the department. So fill that out as well. That takes 30 seconds to fill out. And yeah. Okay. So the final, that is next Friday. So all of this stuff is on Canvas, by the way. So if you ever need a refresher, so it's on Canvas. It's going to be next Friday at 8:30, or sorry, not 8:30. I'm thinking about my other class. The final is at 11:30 next Friday, and you have 24 hours to complete it. Okay, yeah, I think it's the ABET survey. Yeah, I'm pretty sure. So yeah, final next Friday, 11:30, 24 hours to complete it. It's going to be on Canvas. So you're going to submit it as an assignment. I'm going to make that assignment probably later today. So it'll be an assignment, turn it in on Canvas. So you have 24 hours to complete it, but it's not going to take longer than what a normal final would take. I'm just giving you 24 hours just for more flexibility with your other finals and whatnot. And for completing it, basically I'll post the final on Canvas, and if you want to print it out and write your answers by hand, I know some people prefer that, you can do that and just basically take pictures that I can actually read, or scan it and then upload it to Canvas. Or if you have a tablet, you can write your answers that way for the final as well. Or you can get the PDF and you can type out your answers if you prefer doing that as well. I don't really care. Whatever works best for you is fine, as long as I can read your answers. All right. And let's see. Oh yeah, obviously you got to do it on your own, so don't work with other people. I'm giving you 24 hours, so there's really no excuse to not do it on your own. So I'm trusting that you do it on your own, and it's obvious anyways if you're sharing answers with people. It's a lot more obvious than I think people realize. So work on it by yourself. Okay, the study guide, it's available on Canvas. You see it right here. And basically, if you fill out this study guide from now till the final, you're going to do well on the final for sure. So what I'm going to do is I'll probably take, I don't know, probably like 10 questions from here, and that'll be on the final. I might make some other questions that aren't on here, so you see that at the very end. There might be 1 or 2 questions that I make and I put on the final, but it's going to be very similar to style for what you see on this study guide here. All right. So I'm not going to give you the answers for the study guide, but we'll just talk about all of these questions so you get an idea of how the final is going to be. So the first one, and this will be on the final for sure, a stress strain diagram. So I'm going to give you like some arbitrary curve for a stress strain diagram, and you're going to have to label some points and regions of interest. So stuff like the proportional limit, the yield point, the UTS, the fracture point, the elastic range, plastic range, stuff like that. Next one is the elastic range versus plastic range. So you're going to have to basically define the differences for the elastic range and plastic range for a stress strain curve. Next one, yield strength and why it's sometimes used over a yield point. So this is back like in our first lab when we used the 0.2% offset method. So sometimes we use that method to define a yield strength versus a yield point. So if you need a refresher, go back to the first lab or the first lecture and refresh yourself on why we use the yield strength sometimes over the yield point. Next one is necking. So again, first lab, you need to define necking and also state what materials this occurs for. So whether that's ductile or brittle. Next one is how an extensometer measures strain versus how a strain gauge measures strain. So labs 1 and 2. Benefits and negatives of the extensometer and the strain gauge. So that was one of the questions you had to answer for the second lab. So that's really just straight from that memo. So you should already know the benefits and negatives of both. Okay, third lab. Where would we place the dial gauge when measuring the maximum deflection for a simply supported beam and why? So again, that was something that we covered in the third lab. So the dial gauge that's used to measure the deflection. So where would we put that to get the maximum deflection and why do we put it at that spot? No, don't write a paragraph for each question. I mean, some questions you gotta write more than others, but a paragraph is too long for most of these questions. I would expect 1 or 2 sentences. Okay, importance of effective length and how it's determined. So this is lab 4 for the column. And, I'll make sure that all the questions on the final are very specific. Okay, and then the importance of radius of gyration to stability. So for that, you can think about the equation that we have for the radius of gyration and how that affects the stability for columns. And then we have the difference of short, intermediate, and long columns. So for that, it's not arbitrary. We use the slenderness ratio for that to determine if it's short, intermediate, or long. And then how each column type fails. So short columns, they fail in a different manner. Different manner than long columns. So discuss that. And I really like the column lab, by the way. So you see there's 1, 2, 3, 4. There's already 4 questions here just on the column lab. So for sure expect at least 2 questions on that for the final. Okay, differences of normal stress, compressive stress, shear stress, and bearing stress. So, and also, I guess I should have included bending stress as well. And that's basically all of the different types of stress that we've looked at in this semester. Right, fracture surface appearance for brittle versus ductile materials. So think about all the experiments that we had. So the first lab, that was, a tension test, okay, and we had failure there. The fourth lab for the column, we also had failure there. Fifth lab, Charpy impact, we had failure from the impact with the pendulum. And then the sixth lab, that was the double shear test. We had shear failure. So this question here, this one is going to be a question where it's probably going to be like a paragraph answer. So Amro, to give more context, I would expect a question like number 14 here. This will be kind of the longest answer that you would have. So I'll probably just have one question that's like this though, where I'll ask you to give kind of an overview of some experiment. So it's not going to be the first experiment because I already gave a short example here. But I'll ask you to, to give the objectives that we had for that experiment and the general procedure. And so for the first experiment, that was a tension test using the MTS tensile machine. And we did this test for 3 different materials. You don't need to be that specific for what the materials were. I just want to see that you actually understood what the experiment was and what we did. So for that, we were logging load data and deformation data, and we converted that to stress and strain to get insight on the material properties itself. And to measure the deformation, we used an extensometer that was attached in the middle of the specimen to get the deformation data. And, we had to make sure that it was nice and perpendicular to the material for the two blades that we have on the extensometer. Yeah, so I would expect an answer kind of similar to that, so about a paragraph long. How many total questions? So it's probably going to be like 10 questions. So I need to look at the final that I gave last semester just to kind of double check the length, but I think it'll be about 10 questions. And, depending on if you're typing out your answers or writing it by hand, I would expect it to be for you to complete it in like an hour's time. So it shouldn't take long. Okay, next one, possible sources of error and how they directly affect results for each experiment. So if I ask you to give sources of error for some experiment, list as many as you can think of. Well, don't go crazy because, if it's like a bullshit answer, then you're not going to get points. It actually needs to be realistic for what we had in the lab. So list some of the sources of error that we had, and you can't just list them and say, yep, that's a source of error. That's kind of pointless. So you need to explain how that was going to affect the results for that experiment. So, for the first lab, for the extensometer, if those blades, if they weren't perpendicular to the material, I'd want you to list that as a source of error, but you need to think about how that was actually going to affect the results for that experiment, just as an example. And then the last thing, so know how to do basic calculations to find normal stress and normal strain. So that's basically labs 1 and 2. Bending stress, that's lab 3. And maybe also the deflection for the beam as well. So we had a formula for that. And then column deflection and critical stress for columns, that's lab 4. So most likely I'm just gonna have one question for calculations, but you should prepare for 1 or 2 questions where you actually need to calculate something. So I don't want that to be, the entire final. That seems pointless to me for a lab. That's why you actually took your stress mechanics class. I'm gonna have this final. The vast majority of the questions are gonna be like what you see on the study guide, where it's basically comprehension based for the labs that we had in person. So expect 1 or 2 questions where you need to calculate something like normal stress or bending stress or whatever. Okay, is it okay to mention one source of error for each experiment? It depends on the experiment, but for that question, I'm just gonna say I'm only gonna talk about one experiment. So I might say for the column lab, what were the sources of error and how did they affect the results? So it's gonna be specific to one experiment. And some of them have more than one source of error, like the column lab, that had quite a few. We had well, I'm not going to list them off right now, but yeah, that one had quite a few. So it depends on the experiment that I'm asking you to discuss. All right, are there any other questions for the study guide here? Any questions on the study guide or the final itself? Okay. All right, so yeah, definitely make sure to take a look at the study guide and fill it out. If you fill it out before the final, it's just gonna make the actual final itself that much faster because again, a lot of the questions that I have on the final are going to be taken from this study guide itself. So the final really it should be a good way for you to get a lot of easy points for this class. So I expect everyone to do well in the final, and if you don't do well, that's really just from a lack of preparation on your part, and you have a full day to do it, so you should definitely do well on it. All right, so before we end it for today, I just want to remind you to do the SOQs for this class. So please do that right after the class. I think only a few people have done it so far for this section. And then also the indirect assessment survey. Check your email for that. You should have one from the department. All right, and then your 6th memo, by the way, that's due, remember, next week. So make sure you do that in time. And also remember that that is only the results section and the discussion section that you have to do for that memo. All right, so that's it. That's it for today, and I guess that's really it for the semester, kind of. I will be in the Zoom call for the 2 hours, 50 minutes that the normal final would be next week. So if you have a question within that time frame, you can go on Zoom and ask me a question, or you can just go on Discord, ask me there. I don't expect people to have any questions, but if you do, I'll be available. So yeah. All right, so with that, thank you guys for a good semester. So I could actually see you in person for the labs, which is good because it's really weird having a lab that's not in person. You can't really do shit. So yeah, it's nice to see all of you in person. Anyways, I guess that's it for this semester. So yep, good luck with your finals. Good luck with this final and the last memo, right? So I'll see you guys maybe around next semester. And yep, that's it. Goodbye.
Thank you, Patrick.
Thank you. Have a good day.
Have a good one.
Thank you.
You too. Yep.
Thanks, Pat. See you later.
Yep. See ya.